Hi, and thanks for joining this presentation designed specifically for the K12 education market and why you should be looking at Ruckus Wireless for your next Wi-Fi deployment. Ruckus Wireless was formed in 2004, and since our inception, we've grown enormously to over 60,000 customers globally in over 200 plus countries, and we have a stockpile of patents that allow us to deliver very unique Wi-Fi technology. Of course, we address the entire wireless LAN market, but for the purpose of today, we're really going to focus on our successes in education and some of the key things that are important to educators in the Wi-Fi space. Here's another snapshot of just some local customers that we'd like to point out. So we have some very significant and very large deployments in the education space. So if you're ever looking for a customer reference or somebody to talk to, just reach out to your local sales rep and we'd be happy to put you in touch. So who's Ruckus? We've really set ourselves apart from the rest of the herd. IDC ranks us up and to the right as one of the clear leaders in the Wi-Fi space. And that's, based on our technology, our innovations, and also the amount of Wi-Fi that we've deployed out there. We're actually the number 3 market share holder globally in the Wi-Fi space. So, what are the most important things for K-12? And this may not be everything that's important to you, but I try to address the things that I hear most often when I walk into a new sales meeting and I meet a new K-12 customer for the very first time. These are the things that most often come up in our meeting. So the first thing is, how can you make my Wi-Fi work better? Because Wi-Fi, it's a black magic, right? You just, you never quite know if it's working or not working, if it's a user error, if it's an application. It's, there's a lot of challenges around Wi-Fi, and everyone just says, can you just make it work for me? So I'm going to spend some time talking about that. I think that's really our core competency and the reason why the majority of K-12 is starting to move to Ruckus Wireless. We're also going to talk about high density deployments. Of course, in education, there's a lot of students and a lot of devices. Typical classroom is at least 30 students and sometimes more, and they could have 1, 2, 3 devices. So now you're talking about some significant density. Also, outdoor coverage and meshing seems to be a new hot topic. So before it was, I just need some coverage in the classrooms. Now I need density, but now I need to take that beyond the classroom. I need to extend that coverage outdoors into the quad, onto the baseball field, even to the pool where we have swim meets. Google Apps for Education. This is absolutely huge right now. So many school districts are moving to Google Apps for Education, and they're just deploying millions and millions of Chromebooks. So we're going to talk about those things. We're also going to talk about BYOD. Is something that's inevitable. Students are going to bring their own devices, and they're going to want to get them onto the network. And staff, teachers, administrators are going to bring their own devices as well, and they're going to want to get those connected. And in doing all that, we've got to define access policies. We've got to do posture assessment, and we've got to address the guests that come on as well. So we're going to kind of pull all of that together because it's really sort of the same topic and solved by the same set of features and software. And then this is table stakes, right? It's got to be easy to use. It's got to be reliable. It's got to give you great visibility into what's going on so you can manage that network. And you got to be able to report on it. So we're going to address those things as well. And then the last thing that we're going to talk about today is the Ruckus white glove treatment. And this is really my favorite part. And then this is the reason why, after all of this, I think a lot of people like to partner with Ruckus, is because we're going to treat you like a true partner. And I'll get into the details here in a minute. So let's talk about how to make my Wi-Fi work extremely well. So, I would argue that features, functionality, all this stuff is important. But if you can't deliver a better user experience, none of that other stuff really matters. So the connection, that underlying connection from the access point to that user's device is what's going to mean the difference between you having a great day as an IT administrator and having a horrible day supporting a Wi-Fi network. So let's dig into this. So what Ruckus has done is we've designed a set of RF enhancements above and beyond the rest of the competition. And we like to sort of categorize all those into this one terminology we call BeamFlex. And BeamFlex is composed of several things, but the most important thing and the most obvious thing is our adaptive antennas. If you look at that AP on the left, that's your traditional access point, right? Those antennas might be external or internal today, but the fact of the matter is they're omnidirectional, and they just radiate a signal right off that chipset in an omnidirectional pattern. Ruckus is the only product on the market that gives you an adaptive antenna array that changes the actual shape of RF on a per packet basis. So what does that look like? Here's an example. So you can see in the example on the left, there's a AP in the center and a client on the right. And so for that data transmission, that lobe of RF coverage is actually focused off towards that client. And then in the second transmission, the AP focuses that signal down into the left. And so there's some really obvious things that come out of this. One of them is increased coverage, right? So if you think about it, you've only got so much power that you can leverage. The FCC has capped us all. And so we can take that power and we can focus it in a certain direction, or we can just spread it out everywhere. So I'll give you an analogy that's real popular at Ruckus, and it really paints a good story. So imagine that you've got a light bulb, and you turn on a light bulb, and that light just floods everywhere in the room. That is your traditional access point. Now you take that same 100-watt bulb, right, and you put a little mirror around it like you have in a flashlight, and you can focus that energy, or in a spotlight or a lighthouse. When you focus that energy, you can actually get that light to shine much further, brighter and stronger in the area that you want it. And so in doing that, you get more coverage, but more importantly, what you get is more signal or more transmit power. And that's that orange line across the top. And so what that equates to in the real world is throughput and capacity. So we can't get around the fact that there is a noise floor, right? There's going to be other things communicating in the RF spectrum. And there's also going to be 802.11 interference out there. And so I want you to think about the noise floor and the interference like you're in a crowded place. You know, maybe one of these big conferences that you go to every year. Let's say SEPA, right? You're walking the expo floor, and you're hearing all these people talking. That's the noise. That's that bar across the bottom plus that interference. So if you wanted to communicate with a colleague of yours who's close to you, you may not have to shout at them, right? So if you're right next to an AP, no big deal. But if, as you move further and further away from that AP or further and further away from your colleague, you need to be louder than that noise floor. You're going to have to raise your voice so that they can hear you above that. And the same concept applies to Wi-Fi. And so by delivering and focusing that energy directly in the best path for the client, you can raise that orange bar higher. And you can also lower that noise floor by not being a self-interferer. And so you solve this equation right here. If you're not familiar with those acronyms there, the one on the left is signal to noise ratio, and the one on the right is signal to interference noise ratio. And those are the key determining factors of what each client's throughput is going to be. And so if you want to deliver more throughput to each client so that they can get on and off the airwaves faster and make them available for the next client, you've got to give them more signal. The other thing here is interference, right? It's inevitable. We can be louder than interference, But what's really amazing about adapting and changing your RF in real time is the ability to move around interference, and the ability to ignore interference, which is another unique benefit of the Ruckus BeamFlex technology. Now, interference is a killer. This graph gives you a good idea. Every time there's interference and you have to send a retry or retransmit the same frame, you usually have to do a back off and then retransmit. So it's a domino effect, and pretty soon as you get more and more clients and more retries, your network can come to a screeching halt. That's why it's so important to deliver a good quality signal the very first time and maintain that. Otherwise, your performance will just go to hell in a handbasket. So we call this BeamFlex, and that's what's pictured there on the bottom. And the reason I put this slide up there is because there's a lot of folks out there that are touting beamforming. And really, I wanted you to understand the difference between beamforming and BeamFlex. Beamforming is, you can think of this as an echo, right? A signal is sent, but it's sent out of multiple antennas, but it's still omnidirectional. It's just sent at a little bit different times, so there's an echo. And the hope is that those two echoes will catch up to each other and not be an echo anymore, but actually give you more gain, or 2x the signal, because they've combined. They've given you constructive a constructive signal. Another way to look at this is, imagine that you're a DJ and you're setting up your speakers, and you've got somebody helping you at the end of the hall, and you turn those speakers and you focus them right at that person, and if you've got them aligned just right, where they are, they can hear that song much louder. But if you turn one just off a little bit, they're going to hear an echo. So that's the idea here. We're trying to use echoes to make signals stronger. But there's a real trade-off with that, and I'll explain that here. So there's this concept of spatial multiplexing. And in today's access points, you're paying for those radio chains. You've probably seen, looking at data sheets, that an access point is either a 2-stream or a 3-stream or a 4-stream. And it might be 3x3, 4x4. So look for that next time you look at an access point. This is an example of a 2-stream access point. Those two transmit antennas, they can do two different things. They can send the same set of data out of both of them as an echo in the previous example, transmit beamforming. Or if you're using BeamFlex, you can take 2 sets of data and send them both out simultaneously, so you get more throughput. And that's really what we want to do. So the advantage that Ruckus has is we have the ability to use BeamFlex first to get better spatial multiplexing, more total available throughput to the clients. And as a last resort, because this is a chip-based technology, we can always default to leveraging transmit beamforming in addition to BeamFlex. But I just wanted to make it clear that these are 2 key technologies to help deliver signal, but only one of them is available to everyone else, and that's transmit beamforming. Ruckus is using both of these technologies on top of each other to deliver better quality signal, but also more throughput. And we've actually taken that one step further, and this is one of those 100+ patents that we have. We do this thing called polarization diversity with maximal ratio combining, which is a really fancy way of just saying that we can listen for different types of signals that are available. And if you think about today's mobile world, you've got devices that you might be laying flat on the table, holding upright, or horizontally because you're watching a video. They're sending out signals on different planes of polarization. If your access point can only hear on one plane of polarization, you're losing a lot of signal. In fact, we've measured that being able to listen and send on both planes of polarization can give you 5 times the performance. And so this is how it works. So this source device, let's say this is your iPhone on the left here. It sends out a signal, And that signal actually bounces and reflects, and it becomes many signals in the environment after it has multipath reflection. And on the right there, what you see is our AP with multiple antennas that are able to pick up all those copies and on different planes of polarization and combine them to give you one good clean signal. It's just another reason why Ruckus Wireless products are outperforming the competition. So, that's a lot of the stuff that we're doing in RF. We do a lot of innovation there. But once you move beyond that, there's so many other things that are important to performance. So we provide a full quality of service engine, packet inspection, advanced queuing and scheduling. We also have a patented channel algorithm that can optimize RF channel selection based on throughput, not just interference. Most people just look at interference and they move to a different channel. But we want to pick the best channel based on what the available throughput is. And in that scenario, you're going to get the best aggregate available throughput for all of your clients. We also provide airtime fairness. So what this does is it allocates a certain slice of time for each client so that you don't have one client get on first and then start hogging all the air and nobody else can communicate. This is a shared medium, and so this protocol allows us to make every client work well simultaneously. We also support band steering. So if you're familiar with the two available bands for us today, it's 2.4 gig and 5 gigahertz. And 2.4 is very, very congested for a number of reasons we won't get into. So what we want to do is we want to move 5 gig capable clients up into that cleaner 5 gig band. And so we do that with a technology we call band steering. And in fact, we do a lot of band balancing these days, so we can actually let you customize what percentage of clients you want to be steered up to the 5 gig band versus staying on the 2.4 gig band. Of course, we have full meshing technology, and we'll get into that a little bit here today. And we have all sorts of assessment tools. One that's built in called SpeedFlex, where you can actually test the performance from client to AP and then from AP to controller or from controller to client. So it gives you an idea of how things are operating at every different link in the chain. All right, so we've covered how do I make my Wi-Fi work extremely well. So that's the most important thing. Now we can move on to high density deployments. So this might look familiar to you. You've got these, lecture halls or multi-purpose rooms or just any typical classroom, and you might have lots and lots of students connecting in those classrooms. And they may be asked to go to a website, watch a video, access Rosetta Stone language software, or something that requires a lot of throughput. We just recently had a school district do a live NASA feed, and they had 130 devices streaming an unbuffered NASA speed. So that's just an example of things that are happening in these high density classrooms. So Ruckus has introduced a Wave 2 access point that is a 4 by 4 by 4. So it's a 4 spatial stream, 4 send and 4 receive radio chain access point. It's the highest performing access point on the market with support for up to 512 simultaneous clients and gigabit Wi-Fi speeds. It supports link aggregation on 2 gigabit Ethernet ports so that you can support all those high throughput requirements. So I want to give you an example. We certainly do a lot of testing ourselves, but the testing I like to share is the third-party testing and bake-offs, because these are the things that nobody can refute. And we have a legacy of winning these tests. So this is just one of the tests out of many that was done by CarNet recently, and they tested just about all the major players' Wi-Fi access points. And in this 60 client test for high density with a mix of N and AC clients, we outperform the competition not only with our high-end AP, but also our mid-range AP, and by a considerable margin. As we look back in history to our high-end N access point over there, tested by Syracuse University, the Wireless LAN Professionals iPad video bake-off, and going all the way back to the first 2-stream N access points that were delivered to market, we've consistently, using BeamFlex, provided more available throughput with more connected clients year after year. So that's high density deployments in a nutshell. The other thing that I hear so often is outdoor coverage. Okay, so I've got a swim meet, and they track everything online. They've got all these new apps for swim meets. It's all in the cloud, and so they've got to have Wi-Fi at the pool. No problem. Here's an example. We had a customer who said, "Hey, I've got this outdoor AP. You guys said it was IP67 rated, and that means I could submerge it up to 1 meter of water." And we said, "Yeah, sure, you could do that." And so they actually put the access point in the water and submerged it for the swim meet. Kind of an interesting test, and it worked. And that was what got them to buy Ruckus. We're also seeing coaches, physical education teachers, they're throwing the clipboards out and they're going with iPads to take attendance, to plan out their activities, and some more advanced applications where they can actually, in real time, check performance and analyze, swings and throws and you name it, and provide real-time feedback to their players. And all of this is backboned over a Wi-Fi network. So we're putting Wi-Fi in the pools, we're putting it on the baseball fields, on the football fields, and we're doing most of it with our outdoor APs, and sometimes with a combination of outdoor and indoor APs. So all of our access points mesh. You can mesh an indoor AP to an outdoor AP, an outdoor AP to an outdoor AP, or vice versa. They all work together seamlessly under one platform. And really this all happens automatically. Once an AP is found our controller, it has the ability to become a mesh AP, and you just unplug it and go provide it power somewhere, and it's going to find its way home through a neighboring active node that has a wired connection. And it's going to use best path selection and interference mitigation techniques to make those decisions. And it's constantly looking and self-healing to give you the most reliable and highly available mesh network. We talked about channel fly a bit before. It's all about picking the right channels for the best performance. And so we're actually leveraging that through our mesh network to improve capacity. And our field tests have proved that it does improve capacity by about 50%. So that's outdoor coverage and meshing. Now let's move on to Google Apps for Education, Chromebook deployments, BYOD, access policies, posture assessment, and guest access. So this is what yesterday's network looked like. It was real simple, right? We had guests, and then we had IT assets. You would start with a company, or you'd go to school, and there would be a computer there for you. But in today's world, we've got the short-term guests who are just there for the day on campus, maybe a substitute teacher, maybe a parent. Then we've got students who bring in their own devices. They've got iPhones, they've got Androids, they've got iPads, they may have their own laptops, their own Chromebooks. They are going to bring their own devices. We've got the administrators, we've got the teachers. They got their own devices. And of course, contractors, partners, it's just anybody on the administrative side who's maybe not a full-time employee of the district or of the school, but needs some level of access. And we still have those IT assets, right? We've got Chromebook carts, we've got iPad carts, we've got laptops in the library. We've got all these assets that are owned and managed by IT. And so we've got to address all of these, and we've got to give them the appropriate privileges for their type of device and the user that's connecting on that device. And so we do all of that with one software package, and that's Cloudpath. So what it gives you is a plethora of different software functionality to address all of these things. So the first thing is automated onboarding, right? So getting all these devices on shouldn't be something that the IT administrator is required to do. Most don't have the bandwidth to do this. And so we've made this a completely self-service portal where folks can come in and they can automatically provision their device onto the network. No matter what class or what type of user they are, they can get it on, and it's easy. There's always going to be a handful of folks you have to touch, but now it's a handful. It's not every single device. It makes your life a lot easier. This whole architecture is built around certificates. There's a lot of other solutions out there that claim to do all this stuff, but they're doing it with passwords and other techniques. This is really the most robust way to do it with certificate infrastructure. So you can build policy-enabled certificates, and you can tie them to the user, that device, or together between the user and the device, and not use passwords. Of course, we can give you device visibility now because we can track every unique device, who's on it, what type of device it is, and why they're on your network. So this is the gold standard for security, right? Certificates have been for a long time. And in doing all of this, we can start to do that access policy stuff that I talked about. So let's put them on the right VLAN. Let's create ACLs, user policies, and also device control. You may decide, hey, I don't want that Nintendo DS or that mobile gaming device on my network. Or maybe I do, but I'm gonna limit it to certain things. So based on the type of device, you can actually control how and people access your network. Of course, we have a very broad device support. So iOS, Android, Chrome, Mac, Windows, Linux, even BlackBerry. There's so many different operating systems out there, and we support them all very well. We have a very strong focus on the key ones like Mac, Windows, iOS, Android, and Chrome right now. And of course, it gives you reliability, because Wi-Fi reliability is not just RF, it also extends to how easy is it to get onto the network and how secure is it. And so in using certificates, we can eliminate a lot of the pitfalls that people run into with password related disconnects. So, why are passwords so bad? What am I getting at here? Well, some of this may be obvious, right? People share passwords. Teacher, needs to get the student on, so they, because they're having a problem, so they just log into their device for them. Now that password has been shared onto that student device. People fat finger their password, and if they do it enough times, they might get locked out. You might have a password change policy, and the day that policy comes into effect, you've got folks running around with their heads cut off because they can't get on the network. Also, if you haven't experienced this before, think about the last time you changed your password on your laptop, and you use that same password, and it's cached on your iPhone and maybe your iPad. And then all of a sudden, those devices keep trying to connect to the network, and then they lock you out. And you get kind of stuck in this, this black hole of, being locked out and trying to change your password. So we want to get around all of that. And of course, people forget their passwords, so they end up writing them down on pieces of paper, and it's just, there's a laundry list of issues with passwords. So, moving to certificates solves a lot of that. What we can do is we can issue a certificate for each device after they've logged in that first time. So we're still authenticating the user against the user database the first time. But once they're authenticated, their device is going to stay persistent on the network for as long as you want it to be there. We'll still check the database, Active Directory, or Google Apps to make sure they're still a valid user. But when that user comes on, now they're just on. So you don't have to worry about them having problems every day. It's going to be easy for them, but you still have that gold standard in security. Nobody's going to be trying to brute force crack with a password because they're going to need a certificate to get on. So that solves the password leaks, sharing of passwords, social engineering attacks, where people are phishing for passwords, or evil twin attacks. Because you've issued a certificate for every device, you've got visibility and control down to each device. If I blocked myself or my username or any username in the database, that blocks all the devices. But maybe I just want to block one offending device, but keep that user on the network. And of course, for each one of these devices now, through that certificate, I can build policies around that. So we've taken this certificate control mechanism and we push it into the Google console, which is perfect for K-12 education because a lot of you folks out there do have Chromebooks and the Google admin console. So we can deploy the Cloudpath extension via the Google console, and then it's hands-free. You can get a certificate down to each one of those Chromebooks. It'll actually install into the TPM of a Chromebook, which is fantastic that all Chrome devices have a TPM chip. So you can put the user and device certificates in there, and it's all secure. They can't pull those out of there. Perfect solution. And of course, same as with any device with a certificate, we've got the ability to build access controls, VLANs, set policies, all that stuff. And all of this is all built into the product. So we have a fully built-in PKI, but if you already use Microsoft CA or something like that, we can point to that. So we're not asking you to pull that out if you already have something set up, but if you want a real easy to use, all built-in, all-in-one place solution, we're a full PKI, a full radius, full onboarding, full guest sponsorship platform, all in one. Now let's talk about those guests. So these are the temporary users that are there for a day or a week. And, you sort of have a choice, right? And depending on what district I go to, they're somewhere along this scale. So, and I tend to find that most people are on the weak side, right? They want it to be really easy to join the network. So they've written some controls and they said, going straight out the internet, you have the most restrictive policy enforcement. There's a lot of sites you can't get to through our iBoss or our Palo Alto networks box. So we've really locked that guest network down. We've maybe even done some rate limiting on it. And all you have to do is click to join. So you can do that, but a lot of K-12 is starting to ask, well, okay, I need to positively identify these people. I need to know who they are, and if I do that, they tend to be better on my network. And so, but I still want it to be easy. I don't want it to be difficult. I don't want them to ask me every time they have somebody new on campus to get on. And so what we do is we offer social media logins, so they can log in via their Google, Facebook, LinkedIn accounts, or they can self-register by entering in information about themselves. So you can collect all that data so you know who they are. You can also validate them through SMS or through email. So you ask for their phone number, their email address, and if it's valid, then the key is sent to them. And that way we've got one more piece of data on them. And then what's even stronger is if you do some combination of that with sponsorship, or maybe just sponsorship where you ask them who they are, and then you ask them who are they there to see. And they type in who they're there to see, and it sends an email off to their sponsorship host, who then clicks and approves that user to come on as a guest. And then once all of this happens, they're treated in the same way everyone else is. Certificates push to their device, so we got the same visibility and control, link layer encryption, everything that our staff and our students get from an encryption and security perspective, our guests also get. So that was those sections. Now, I want to talk about table stakes. I think this is absolutely critical. You have to have this. If you're an enterprise Wi-Fi player and you don't do this stuff, then you shouldn't even be in the game. But I'm going to tell you how Ruckus does it because I think we do a great job of these things. So, how do I make it easy to use, reliable, provide great visibility and reporting? So our Smartzone solution architecture is our control plane architecture, right? It's how we manage, how we onboard our access points, how we get visibility into them. And we make this available to our customers either controllerless, a cluster of APs is the control plane, or as a VM, or as an appliance they can buy, or as a public cloud offering. So we've made every option available to you. You pick and choose which one you want. And once you've selected that, you're going to get scalability. Our controllers and our VMs can scale up to 30,000 access points and handle global deployments. You get resiliency. So this is full AP survivability. If you were to lose that entire control plane stack, the APs are going to continue to survive during that outage. Although that's highly unlikely, it's still available to you. And we're going to give you the flexibility to either tunnel traffic or not tunnel traffic, dynamically assign traffic out onto a VLAN. And in this controller architecture, we're going to give you the ability to cluster controllers, not just for scalability, but also for resiliency. So if you were to lose a controller, the other controllers would take over. And it's all hot swappable. So there's zero loss to the clients. There's no service interruption to your access points. Everything continues to run, and then you just plug in a new box and it will rebuild itself and join the cluster. We also give you a single pane of glass. Even across a multi-node cluster, you're going to go to one place to see everything across your entire network. And I think we've got a really, really nice console. It's all web-based, and if you can see across the top there, we're looking at the dashboard right now, and there's 4 other screens. So there's your monitor page. You click on that, and you get a list of all the different monitoring pages, from monitoring your access points to your clients to a map view, you name it. It's all in one page. Everything is 2 clicks away. You go to the configuration tab, and that's where you go build your WLAN configurations, set up your AAA server, whatever it is you need to do to configure your wireless network, you can find under the configuration tab and a sub tab. Again, all 2 clicks away. Full onboard reporting. And then the administrative tab is just to build those unique usernames for access into the system, or to tie that to TACACS or Active Directory or whatever database you'd like for your IT staff to access the system. And each unique user has the ability to customize things, customize their own dashboards and whatnot in the system. We also give you role-based access, so you can very granularly define what each user has access to in the system, whether it be just visibility or control for a host of different functions. We've integrated Google Maps so that you can at a glance see all of your access points wherever they're, across the entire city, the entire county, and you can very quickly see what's up and what's down, or if any have alerts, and you can click right in onto those, and it'll take you to the respective pages to show you what's going on with that AP or the clients that are associated to it. We provide robust and customizable Wi-Fi reporting. One of the unique things that I think Ruckus offers that most other vendors don't offer is a complete report designer so that you can build a report from the ground up, and historical data that's saved on all data points. So we're not averaging data out by the week or the month. So you can actually go back to your week of testing last year and compare it to your week of testing this year. You can't do that with other platforms on the market because the week that you're looking at from last year has already been averaged out. So you're just looking at an average versus real data. And that is one of the unique differentiators with our true big data analytics reporting platform. We also provide location tracking, so we can track all the assets that are in range of your Wi-Fi. And I say in range because they don't actually need to be connected. If they have a Wi-Fi chipset that's on, we're going to track that device, and we're going to tell you exactly where it's at. Now, once they do connect to your network and they start sending data, we're going to get a lot more location information from them, and then we can get 3 to 8 meter accuracy on those specific devices. We can actually go back in time and see where those devices were at different times. If they're missing, if you need to track something down, that's all going to be available to you. Not only that, but you're going to see hotspots of user density. You can see that on the right there. So we're actually going to tell you on a timeline over the course of day, week, month, year, where is the density of the network being used. So you might see at lunchtime in the multi-purpose room in the cafeteria, you're going to see some red spots. You'll see which teachers are the most active on their, on the laptop devices because they're going to have red spots in their rooms. We can also give you average dwell time, unique visitors, repeat visitors, just a wealth of visibility into, how your network is being utilized. So that was that was really the core of what I wanted to talk about today. And now my favorite part, and this is what I'm going to close on, the Ruckus white glove treatment. So we want you to be a VIP, and we want every customer to be a VIP. All you have to do is raise your hand and say, "Hey, I'd like that white glove treatment from you guys, and we're gonna deliver that to you." So that starts with being invited into our headquarters, to our executive briefing center, and starting to meet the members of our executive staff who are going to give you executive sponsorship and support on your project to ensure its success. We're going to introduce you to product management, who's going to give you a peek into the future, what's coming, what new exciting things can you expect, and then also listen to your feedback and find out what's important to you and what would you like to see, because you are now, as a customer, an influencer of our product and our roadmap. And then, of course, a walkthrough so you can see behind the scenes how we run our organization. And some of the things we like to show are the design labs. Ruckus is the only company that really takes a reference design from a chip manufacturer and totally revamps that to give you a better quality access point. So we like to take you in and show you those design labs, and then we'd like to take you in and show you the post-production testing labs. Every single access point that is shipped from Ruckus to an end user is tested. And that's not very common. You got to turn those things on. You got to make sure they're good before you deliver them out there. And you got to measure for tolerances, because you don't want to get an AP that's, only 75% of what you'd expect in terms of performance. That just wouldn't be fair. And you may never know that you've got one weak link out there because it's working. We test all of those things, and we want to show that to you. We also want to introduce you to our top tier 3 support contacts, the guys at Ruckus in Sunnyvale that everything bubbles up to, so that if you ever had any issues and you need to get immediate resolution, you're going to know who to call right away. And for customers that are interested, you've done this successful deployment, it's something that you're proud of, we would like to showcase that. We'd like to do a write-up, a case study, and a video. And take a second, to pause the video, write down that URL, and then go take a look at this San Francisco Unified School District example. We'd also like to introduce you to a dedicated field engineer who's going to support your project and make sure your install is successful. We'd also like to give you competitor trading credit. So if you're not a Ruckus customer already today and you've got a different manufacturer out there, we want to talk to you about how we can buy that equipment back so you can become a 100% Ruckus customer. We want to give you access to new products through our beta program so you can test those and see what's coming and see if it's right for your network, and also help us improve our products so that when we deliver them, we deliver a fully baked product to you, it's as best as it can be. And my favorite thing is the back scratcher. So, come talk to us and do all this, and when you leave, we're going to send you home with a back scratcher to remind you that Ruckus has got your back. Thank you.